Hello students, I am Dr. Mansoor. Today we are going to learn about analysis of oils and fats. Analysis of oil and fats is important to maintain the quality because the quality of oil and fats affect the health of consumer and the quality of different products like soap, shampoos and personal care products. The quality of oil and fat is depend on the certain analytical parameters, and these analytical parameters are saponification number or value, acid value, iodine value, acetyl value, Richard Mason number, and Polenske number. One by one, we cover the analytical parameters for the analysis of oil and fats. First is the saponification number. Saponification number means the milligram of potassium hydroxide required to saponify 1 gram of fat or oil completely. And this can understand by using this chemical reaction. This is a triglyceride in fat or oil, and it is hydrolyzed with the potassium hydroxide to form glycerol and the sodium salt of fatty acid, that is the soap. So this reaction is saponification reaction. So here the condition are specified for the saponification number, that fat is taken as 1 gram, and here the amount of potassium hydroxide in milligram required to completely saponify 1 gram of fat. This amount of KOH is known as the saponification number. Saponification number is very diagnostic parameter, and it is used for the determination of molecular weight of fat and oil, because the saponification number of fat and oil is inversely proportional to their molecular weight. So this is very useful for calculation of the average molecular weight of fat and the oil. This table shows the average molecular weight of fat and oil with their saponification value. So from this table, it is clear that more the saponification value, less is the average molecular weight. In this way, saponification number is used as diagnostic parameter for identification of fat and oil. We can detect the adulteration in given oil and fat with the help of the saponification number. Second parameter is the acid value. So acid value is used for the detection of free fatty acid generated by rancidity in the given fat or the oil. The milligrams of potassium hydroxide required to neutralize free fatty acid in 1 gram of fat or oil is known as the acid value of given fat or oil. We can understand this by using this chemical reaction. This is the free fatty acid generated in fats and oils by rancidity. So here this free fatty acid is neutralized by use of the KOH to form the salt like soap and the water. So the milligram of KOH required to neutralize free fatty acid in 1 gram of fat and oil, this is known as the acid value. Acid value is used for the detection of free fatty acids in fats or oil, and the good quality of fats and oil are free from any kind of free fatty acid. So it is used for the free fatty acids are formed in fats and oil due to chemical or bacterial contamination of fats and oil, resulting into deterioration of the fats and oil, and this is known as the rancidity. So acid value is measure of the rancidity, extent of rancidity in the fats and the oil. The third parameter is iodine number. The unsaturated fatty acid contains the unsaturation in the form of carbon-carbon double bond, and that carbon-carbon double bond consumes the iodine to form the addition product. So the grams of iodine consumed by 100 gram of fat or oil is known as the iodine number. We can understand by using this chemical reaction. This is unsaturated fat containing number of carbon-carbon double bond. So unsaturation is represented by this carbon-carbon double bond. This unsaturated fatty acid, the carbon-carbon double bond undergoes addition with the molecular iodine to form diiodo derivative of the fats or the oil. So here iodine number is a measure of relative unsaturation, means carbon-carbon double bond in fats on oil. Using the iodine number, we can identify the fat. So iodine number is used as a diagnostic parameter for identification of unsaturated fat and oil. So using the iodine number, we can differentiate given fat is saturated or unsaturated. The saturated fat is having the zero value of iodine number because iodine is not consumed, but unsaturated fat is having the value iodine value larger than the zero because it undergoes addition of the addition. So iodine is consumed by the unsaturated fats on oil. This table shows the iodine value of the unsaturated fats and oil with their unsaturation category. So from this table, it is clear that higher the iodine value, more is the unsaturation. Means that fat or oil contains the large number of carbon-carbon double bond. Adulteration in given unsaturated oil, in oil and the fat can be easily detected by using the iodine value. So just like the saponification number, the iodine value is a diagnostic parameter for identification of the oil and the fat. Saponification value is a diagnostic parameter for identification of all type of the fats and oil, but iodine value is parameter for detection of or identification of only unsaturated fats and the oil. Next parameter is the acetyl value. So acetic anhydride is used for the acylation of hydroxyl group, pre-hydroxyl group in fats and the oil, resulting into generation of the acetic acid. That acetic acid is generated during the hydrolysis of the acylated of the fat, and that acetic acid is titrated with the potassium hydroxide. So the milligrams of potassium hydroxide required to neutralization of acetic acid produced by hydrolysis of 1 gram of acylated fat and oil is known as the acetyl value. So this is the reaction. In first step, that free hydroxyl group in the form of alcohol or free fatty acid in the fat on the oil is acylated by using that acetic anhydride to form acetic acid and the acylated fat. So acetic acid is generated during the acylation of the fat. That generated acetic acid is neutralized with the help of this potassium hydroxide to form potassium acetate salt. So here the milligram of potassium hydroxide required for the neutralization of acetic acid produced during the hydrolysis of acylated of 1 gram of fat is known as the acetyl value. So acetyl value is a measure of number of pre-hydroxyl group in the fats and the oil. That pre-hydroxyl group can be present in the form of hydroxyl group, that is alcohol or free fatty acid, and that free fatty acid or alcohol undergoes acylation to form acetic acid. So we can count the number of hydroxyl group in given fat in oil and the fat. So acetyl value is a measure of number of hydroxyl group in fats and the oil, and that free fatty acid or free hydroxyl group are formed in the fats and oil due to chemical or bacterial contamination of fat and oil, and hydroxyl group increases. This is known as the rancidity of the fats and the oil. So we can detect the rancidity of the fats and oil with the help of acetyl value. It means that higher the value of acetyl value, more is the rancidity because number of free fatty acid in the given fats and oil increases. Fifth parameter is the Richard Mason number. Richard Mason number is a milliliter of 0.1 molar KOH solution required for the neutralization of water-soluble volatile fatty acid extracted from 5 gram of saponified fat. This is the extraction of water-soluble volatile fatty acid from the 5 gram of saponified fat, and that water-soluble volatile fatty acid are titrated with the potassium 0.1 molar solution of potassium hydroxide to form salt. So this is the ml or milliliter of 0.1 molar solution KOH required for the complete neutralization of water-soluble volatile fatty acid from saponified fat. This ml of KOH is known as the Richard-Mason number. Richard-Mason number is a measure of quantity of short-chain fatty acids present in the oil and the fat, and this is also useful for detection of adulteration ghee and the butter. Next analytical parameter is the Polenske number. Polenske number is similar to that of the Richard-Mason number, and these two parameters, Richard-Mason number and the Polenske number, are determined by using one experiment only. Difference is that this Richard-Mason number is used for the determination or the neutralization of the water-soluble volatile fatty acid, while Polenske number is used for the water-insoluble volatile fatty acid in the fats or the oil. So, ml or milliliter of the 0.1 molar potassium hydroxide solution required for the neutralization of water-insoluble volatile fatty acid extracted from the 5 gram of saponic fats. So this is the water-insoluble volatile fatty acids are extracted from the 5 gram of saponified fat using the distillation, and that water-insoluble volatile fatty acid are titrated with the milliliter of the potassium hydroxide solution. So the milliliter of the 0.1 molar solution of potassium hydroxide required for the neutralization of water-insoluble volatile fatty acid from 5 gram of the saponified fat is known as the Polenske number. This table shows the Richard-Mason value and the Polenske number of different types of fats and the oil. And in this table, it is clear that butter and the ghee are having the higher value of Richard value. So this Richard-Mason value and Polenske number can be used for the detection of adulteration in butter and the fat.